In order for CCS to be relevant as a climate mitigation measure, we need to scale it up to a gigaton scale. And when doing so, the margins are important. We need to be able to design accurately and safely and efficiently the transportation and injection systems. And one of the things we need to do so is to have an accurate view of how CO2 and CO2-rich mixtures behave. And this is what we measure here in the ExCeL depressurization facility. All right, here we are inside the container of the ExCeL depressurization facility. The heart of the facility is this vessel, as you can see here. Here we do experiments for filling, emptying, and storage of CO2. And this is particularly relevant for ship transport. It contains 60 liters of CO2, and we are able to fill it all the way from high pressures and temperatures down to minus 53 degrees we did yesterday. So this vessel is accurately instrumented with several pressure sensors, and you can in particular see the temperature sensors here that measure temperatures in the CO2, near the wall, and also inside the wall, so that we can also calculate heat transfer. When we do depressurization experiments, the CO2 will exit here through a nozzle and out to the atmosphere. And at the same time, because this vessel is placed on scales, we can measure the mass flow. And one device that we are happy with is the nozzle that resides inside here, because with this we can measure the state of the choke point, which is of importance for model development. This is the ExCeL depressurization pipe. So it's a 60-meter long pipe starting from the wall over there, and it ends inside this containment. What we do is that we've pressurized the tube with CO2 or a CO2-rich mixture. And at the end here, which you can't see because it's protected, we have a holder like this, and it holds a rupture disc. And this rupture disc is calibrated to burst at a given pressure. So when we have reached this pressure, well, it will look like this afterwards. And then we have very fast pressure sensors that can measure the depressurization wave as it moves upstream towards the wall there. With these kinds of experiments, we develop and validate transient flow models for CO2. And they are used in the calculation of flow in pipes, and also in particular for the calculation of running ductile fracture, which is one important parameter that we need to design CO2 pipes against.